Okay, so here's a look at all the components that make up the multi-gauge for the NC Miata. Here's the main PCB. Next we have a flexible PCB. This is essentially an extension for the display itself. It's very thin, very flexible. This allows us to get the signals from the display outside of the gauge cluster without modifying the gauge cluster at all. This is the display. It's a 240 by 240 pixel round display, 1.28 inches in diameter. The communication method is SPI, and it is currently running at 80 megahertz. This is what would get soldered onto this flexible PCB and allow us to make the connections we need to make. Next, we'll look at a completed PCB. So it's in an enclosure currently. This is a button for input. We have USB-C for programming the main microcontroller. We have an RJ45 port for the display and a 14-pin connection for all the sensor inputs as well as power and ground. So this button is just an extension, and we'll take this out. So like I said earlier, USB-C, RJ45 for display, 14-pin connection. Here is a 4-pin connector for an expansion PCB. Essentially, if you want to add additional sensors, this is an I2C port where you could easily add another PCB that I have yet to design, future expansion basically. Right here is the ESP32 Rover. This PCB is actually designed to work with a Rover or Vroom. Basically, the Rover has additional RAM in the form of PSRAM. It's not really necessary for this application, but they essentially cost the same, so I just buy the Rovers. Right here we have a buzzer for audible alerts, USB chip. This is our main analog to digital converter chip here. This gives us much greater precision in terms of reading the sensors rather than using the built-in analog to digital converters in the ESP32. Okay, here is a completed flexible flex PCB. As you can see, you have another RJ45 port. This is the other end of, where the cable between the main board and the display would connect. A couple components on here, a couple of resistors, a couple of capacitors, one transistor. Next, we have the main harness for connecting all the sensors. You got power and ground. This wire is for connecting to the illumination wire within the car, so the gauge can automatically know when it needs to dim the display. And then we got a connection for the field pressure sensor. You got power, ground, and sensor input. This is for a optional switch. So if you want to mount your main control box somewhere where that button on it's not going to be very accessible, you can connect an additional push button or tactile switch button to this wire to perform the same operations. The blue wire marked ethanol is going to connect to a signal wire coming off our Zetronics ethanol CAN bus adapter. That's how we're going to read the ethanol content percentage. And then we have a 3-wire connection for your oil pressure sensor and a 3-wire connection for your boost pressure sensor. And then of course you have a Ethernet cable, Cat 6. And this is a bezel for the display. It's currently painted with primer. I'm in the process of smoothing it out before I paint it a nice matte black to blend in with the gauge cluster. And those are all the main components.